Not- yeah. Well, well, hello, woodworkers. I'm glad to see you all here, and I'm also hopeful that there'll be people who'll be tuning in to see us on YouTube tonight. This is the first of NAA. It's the first time that we have a monthly meeting from our shop. And I hope that we'll be able to do more of this in the future. Because excuse me, because the logistics are a lot easier here for us, and we have access to our shop. So it's really a win-win type of situation. We'll be, probably going, using Shaker Heritage also sometimes, but it's going to be a balance. And if we get to the point that we can't accommodate our members here, well, we do have the Shaker Meeting House, so that's a plus. I would like to, at this time, to thank Carl Stoner, who has made one major, almost heroic effort to get this type of programming possible for us, and his able assistant, of course, Dave Mobley. Thank you, gentlemen. There's a plug I also want to make for an upcoming event, which is the showcase in March. And Maria Witkins is in the back. She's the volunteer coordinator. She may not let you leave here without volunteering.
I got all the forms, guys.
You got them, okay. All right. For the new members, I know we do have some here tonight. Showcase takes about 200 member volunteers to be pulled off. 400 volunteers? 400. Well, you're probably right. I'll go with that. It's a main regional event, and if you're brand new to NAA, I would say volunteer to find out just how large NAA is in all of its various forms and types of people. It's a wonderful event. And what we're going to do now, we just added to the script, let's have a brief Insta gallery, which for new members, if you haven't had any meetings to be around, is a time for members to bring in to a monthly meeting and actually show off a piece that they've been working on, or to talk about the problem that they had with it, and it's a time to kind of catch up on what other people have been doing. So with that, I think I'll turn it over to Carl Stoner. Thank you, Carl.
I believe we have some people that have brought in something for. Did you? If you want to come over, bring it over here and talk about it. I'll hold this.
Guitar number 37 for me. My name is Eric Marzak, and then I've been in the club for a while, just re-enlisted. It's got made out of some sugar maple that I cut down about 40 years ago up in West Sand Lake, so it's some local woods. Neck's made out of Spanish cedar. The top is a nice piece of bear claw German spruce, ebony fingerboard, an East Indian rosewood bridge, and I cut my own, the nuts and the saddles I cut from deer bone that people give me. And the binding is Ziracote, and I do the inlays myself I'd make up little blocks and make up these little tiles. As a matter of fact, this is what we make. A long bar with these little tiny sticks of wood, so it's like micro inlay. And you slice them off and make tiles and glue them in, fit them in, glue it. And so number 37 for me. Oh, yeah, yeah. It's just got new strings on it, so it's going out of very quickly now. It'll take about 2-3 weeks to settle in.
Slice them with a handsaw?
What, these?
Jeweler saw?
Yeah, I just use a small, it's an X-Acto saw with the razor blade on it, and I cut them about 2 millimeters. You have to route out this area around here. Matter of fact, we did a class on it one time for the turners, and Wally has one of my turning pieces where I basically use the same inlay pattern for the rims, and it really works out nice. And if anybody's interested, I can show you how to make these up and use them for your turnings and whatnot. So, thank you.
Thank you.
Finish on that.
Oh, it's French polish. And just in case, there's a LMI is a luthier supply company, and they have a product called Royal Lac and Seal Lac. And indeed, the Royal Lac after 30 days of curing is alcohol proof. I mean, for a little while, you can wipe alcohol on it and wipe it right off, and it doesn't dissolve the shellac at all. They put some polyester material in it, and it's great waterproof finish. Yep, and very thin too, so it doesn't. If you use a lot of lacquer on it, that'll definitely cloud the sound out. So you want a nice thin finish on the top. Thank you.
Does anyone else have anything for Instant Gallery? We do have a number of things on the table back there that are part of the program, so we'll be showing those a little bit later. Oh, okay.
So I just wanted to, we haven't had showcase in a while, but this year's showcase, the last showcase we did have, I allowed members to put their pieces in to sell in the store, and I will be doing that again. There will be an application in the January newsletter, and the NWA will be taking 25%. So you really can't get much better than that. You don't have to be there. I would, if you have a number of things, it'd be helpful if you wanted to work a shift, but you don't have to. But it is juried. I mean, so it has to meet certain standards. So but most of you people probably have nice things, so it's fine. So the way it works is you tell me you're going to do it, you take pictures of it, you send it to, and then you bring it on Friday. And then we set it up and get the price tag and stuff on it. And then at the end of the show, you check to see if it's still there or you have to pick it up. So, but again, it'll be in the newsletter, but if you want to start making something, or if you want to donate things to the store to help the NWA, we're open to that too.
Thank you. Anything else? Okay. Well, tonight our special program is Kurt Albright, and I would like to ask Dave to come up and introduce him.
Well, Carl, in a way, you've already introduced him. But so Kurt is a relatively new member to NWA. Of course, everyone is a relatively new member compared to me and some of the others. But Albright. So Kurt works at as a researcher over here at SUNY Polytechnic in the Nanosciences College, and earlier this year I noticed that Kurt was on one of our Zoom call meetings, and it came up somehow it came up a discussion of doing CNC or laser work on some pieces, and so I took note of the fact that he, like me, has both a CNC and a laser. So when I was contacted to possibly put together a program here about CNC for woodworking, one of my first thoughts was to get in touch with Kurt. Kurt also, in addition to his day job, he has a setup over in Troy where he lives with both a CNC and laser engraving. And tonight he'll be focusing on CNC work for woodworking. So thank you for joining us, Kurt.
And as was mentioned earlier, oh, I gotta turn this on, don't I? Are we getting feedback on that? Is that pretty good? Everybody can hear? Excellent. All right. So this is going to be a little bit, I think as was mentioned before, this is the first time we're running this sort of hybrid presentation thing. So if we have some hiccups, we'll learn along the way. It's always good to mess up and learn a little bit along the way. So yeah, I would first like to thank, oh, we need to get over. There we go. Dave and Ernie for their contributions. I do apologize right now that I didn't get more of your pictures into the presentation, but we have lots of stuff in the back there to take a look at, and they can explain, or Dave can explain sort of what we're seeing back there. I think afterwards we'll do like a show and tell kind of a thing. That sounds good. Yeah. All right, so I own and operate Carriage Factory, bespoke manufacturing in Troy. It is very much at this point my side gig. I work across the street. I specialize in photolithography. But in my off time, I have a full traditional wood shop as well as CNC and laser engraving. Full disclosure right now, most of my business at this point is laser engraving. There's always seems to be some sort of a market for that with one thing or another, particularly right now as we come up to the holidays. This talk is designed as an absolute beginner sort of a thing. All right, so let's get this out of the way right now to determine how much lying I can do. How many people already have a CNC tool? Oh, I can get away with a lot of lying. Nice. Okay, good. So I'm not going to go into absolutely all our, feeds and speeds and figuring out all sorts of things and all that. We're going to talk about the process, what we can do, how we can integrate into our shops as they are, or replace tools that we already have. I'm going to keep it basic. I'm going to try to do some demos in the software that I have on this computer, as well as try to sort of show a simulation of how we might machine. We were supposed to have an actual machining going on later, but I don't know that that's happening now. I think we're having technical difficulties. So, and I would also like to get out of the way right now that I am not affiliated with either ShopBot or Vectrix software. However, those are the items that I do use, and they're the ones that I'm going to reference probably the most often. So let's get that out of the way right now. I don't make any money off of it. I'm just an enthusiast. All right. Oh, it'd help if I switch that one. There we go. What are we going to talk about? As I said, we're going to go into what is going to make up our CNC system. How do we tell it what we want it to do? What is the process flow going to look like from conceptualizing everything to programming it out to actually cutting the thing that we want to cut? Hopefully making it look like what our brain thought it was going to look like. Always the big challenge with CNC is you don't know until you're holding it at the end, whether it gets flung across the room or whatever. So there we go. Talk a little bit about what we can hope to accomplish with our CNC, what kind of materials we might be able to use, what sort of add-ons we might be looking at. There's all sorts of stuff now that you can add on to your CNC other than just a router. And whether that's good or bad, we can talk about at a later date. Let's see, what else do we got up there? And then, yeah, as I said, we'll try to fit in a couple little demos here. When we talk about CNC, I think the first thing that everybody immediately thinks of is kind of, you have a computer right here, and you have the CNC tool. And as soon as you go out and you tell somebody, I went and I bought myself a CNC tool, there's this sort of immediate assumption that what happens is you conceptualize something, somehow that magically jumps onto the computer, and then you hit like print, and wood gets printed, you know, over here. And let's just stop that right now, because that is just not true. But it's what everybody's going to think as soon as you tell them that you bought one, right? You could do this. You can do that. Well, yeah, probably, maybe down the road. But first, we're going to do some basic stuff, right? So in reality, we have some other components. I'm going to list the router or our spindle as this whole separate piece of equipment in this equation. Mainly because when you're speccing out one of these systems, oftentimes you're going to have to choose that as a separate entity from the machine itself. So if you go and you buy a truck, often you'll buy, you know, you're speccing out the chassis, the size, all that sort of stuff. The engine, you know, is sort of that one piece where you have to make some choices, and your trim levels, things like that. So we're going to talk about the router and the spindle, or the spindle, as a separate entity. Everybody forgets about dust collection. It is like so important. I mean, we all know dust can do some nasty, nasty things. Nothing creates dust like a CNC tool, uncontrolled and unchecked. That's just the reality of how it is. So we need to be factoring that in as we plan to set things up. Tooling. I've got all sorts of stuff up here people can kind of take a look at later if you want, but just because you went and you bought a really nice tool, you got your dust collection, you've got a nice computer, you're going to need to invest in some tooling. Now that tooling is going to consist of everything from your bits to, I'm going to include your hold down solution in tooling, because that's going to be a whole other thing you have to think about. And I'm going to also include some sort of a zeroing method in there. Now oftentimes that's going to be sort of inconsequential. Ooh. But, it's not too bad. Oh, I have it here, so it's all good. I just have to remember to do two things, so that'll be fine. So we've got our tooling. Last but not least, our software. We'll talk a little bit about software. There are so many different solutions out there for software. You could fight about it all day long, and everybody will give you a different opinion. It's like anything else. But you're going to need at some point to choose some some software, both to do your designing and your actual CAM work or programming for the tool. That can be either free, or it can be, think of a number and then double it. So choose wisely, okay? I would also like to, in case I forget at this juncture, somebody remind me that we should probably talk very briefly about the newest thing that everybody seems to want to do, which is pay-as-you-use cloud-based software. So do not get yourself into trouble with that. There was just a big lawsuit about it. I don't know if anybody heard about that with Cricut, the little vinyl cutters. Yeah, big lawsuit about it. They tried to sort of change from one method to another method, and all the people that had bought it thinking one thing were then hooked into a pay-as-you-go system. So pay attention now. This is becoming a big deal. Our workflow. We're going to do our design and our CAD. We're going to do the programming, or the CAM part. And then we're going to actually go into the machining. I'm going to switch over now into my software. What I use is Vectrix Aspire. Vectrix is a British company. They are very prevalent in, I would say, many levels of CNC use. You get it, sometimes you can get free versions of it along with machines that you buy. It's the one that ShopBot, for example, gives away. Not Aspire, but VCarve. They have, I think they're up to about 8 different levels of their software based on what you might need. So that's what we're going to be looking at here. It's what I use. And it's going to take care of both my CAD and my CAM portions of getting our system set up. So what I'd like to do is switch over into the software. And if we can just sort of envision for a minute, because this talk is supposed to be about using our CNC in a woodshop environment. Let's say that guitar is very pretty, so we're not going to mess with that guitar. But let's say we made a little box, a completely unadorned little box. It's very pretty. We did some nice work on it. But we think maybe it could use a little something extra. Now, if you're like me, you don't have experience with hand carving. Lovely though hand carving is, as my wife tells me, I do not have the patience for it. I simply don't think I'd be good at it. But I have a CNC tool. So I have my little box that I've made. It's actually not that little, because I think I set it to 8.5 by 11, so it's quite a large little box. And I'm thinking about it, and I want to put a design on the top of it. How would I go about doing that with a CNC tool? Let's take a little look. If we can find the correct file that I've pulled up here. Okay. I'm going to go into more detail on this stuff. This is the sort of rip through it just so we can see what it looks like section. I have my material here. It's 8.5 by 11, hopefully. Yes. I'm going to say that this little project, I'm going to be giving it to a teacher. Teachers, you know, always get the same thing, which is apples. So we're going to go in here and we're going to use, hopefully, yes, we're going to grab clip art, which is your friend when you're just getting started with CNC. There is no shame in using clip art. It is made for a reason. We're going to pull our little apple in there. This is a piece of 3D clip art that came along with my software. Let's go into this side here. As you can see on the left, you get this sort of grayscale image. This is pretty common with 3D models. You often see them in this grayscale. As a side note, be careful, because just because you have a grayscale image does not mean that that grayscale represents depth. So use caution. And on the right-hand side, we have our material. Now, I've set this to 3/4 of an inch. It's pretty common. We can kind of move it around like this. It's already set into this neat little, oh no, we went away. Come back, Apple. There we are. So I would do this. I would figure out how I'm going to mount this to my machine. I would say, yeah, that looks pretty good. I'm not really going to do much about it. I think we should just make it. Excellent. Now I'm going to cheat a little bit here, so you people that already have a CNC, I'm not going to do a roughing toolpath. Don't yell at me. This is just so it looks good. I figure out what I'm going to be using. I'm going to use, what am I using? Oh, I'm going to use my Amana 1/8 inch tapered ball, which is a lovely tool. Calculate that. And at this point, we're going to get an interesting view of what's going to happen. Now, this is a raster toolpath, meaning it goes back and forth. We could also set this to go out from the middle in little gentle spirals. And away it goes, and away it goes, and away it goes.
This is pretty quick.
Well, that's not going to be the real speed. That's the exciting speed. That's like the warp speed version, where we don't sit around all night and watch it go. We could check.
No, but I mean, even doing the drag part, it was pretty quick.
Oh yeah. Yeah, with the machine constants that I have set up in there, that's a 40-minute job. Now, that may be because I just chose a tool at random. That might not be the right tool. Normally you would use a roughing toolpath to remove the bulk of that material, as opposed to just skimming back and forth. But yeah, using a package like this, and again, doesn't have to be this package, there's lots of other ones, you can do it pretty quickly. And if you use something that's pre-made like this, you could take it, you could modify it to meet your needs, you could add some text in there. You can do a lot of things really quickly to add sort of value to what you've made in the wood shop. Now, normally what I would do is, if I were going to actually send this to my machine, I would then save this toolpath as a set of instructions, which I would then load onto my tool, and it would actually machine it. I'll show you a little picture of what that looks like later. This, any guesses how many lines of code?
5,000? 10,000?
49,500 lines of code.
Who does that?
It just did it. Software does it. That little bar that went across the bottom, that was it calculating 49,500 lines of code. At this point, think about not cheaping out on your computer. Okay? At the same time, this does not require like a gaming system or anything. You can do it. It's fine. It'll be fine. Don't super cheap out, but at the same time, it doesn't have to be crazy. The software is really, they've spent years optimizing this stuff to make this painless. So just go with the painless, please. If you really want to get into tinkering with it and writing your own code later, you can always do that. But when you're just getting started, make it easier on yourself and just buy a package. All right, so let's go back. Oh, we actually went back, yay. All right, that was our demo. Oh, I got excited myself. So now I just like to go in, slow down those steps, since this is an introduction, and just kind of go over what we need and how we're going to do each of those steps. In the first portion that you saw on the left-hand side of my screen, we had a number of drawing tools, things that would look sort of normal to you just from drawing. You can draw boxes, ellipses, lines, all that kind of stuff. You've got clip art, all sorts of things. The thing you need to learn is how to get what's in your mind into that digital medium. That's, I think, the biggest learning curve out of the whole thing. Machining, you can always machine it again if it doesn't come out right? But you have to get that initial thing done, and I think that's where a lot of people get frustrated at the beginning. Look up videos. There's so many tutorials online. They're great. Vectrix got a ton of them. I'm sure every maker on YouTube's got a video of some special thing that they figured out. There's no one answer to how do you get that from here to there. Vectors are a reality, and you're going to have to deal with them. Does everybody know the difference, sort of between vectors and if you're using a program that doesn't use vectors? Anybody used Illustrator before? So Illustrator is vector-based. Vectors have, if you draw a line in a vector-based program, yay, I get to use the whiteboard. It's going to have a definite beginning, a direction, probably something in the middle, and an end. The good thing about using vectors is that they're infinitely scalable. So if we have an image, or this 3D piece of clip art that I used, that's made up of vectors, you can infinitely scale that, within reason, that image to whatever size you want it, and it won't lose definition. If you have a raster image, like CSI or something, they're like, we got to zoom in, on the thing, enhance it. And they enhance it, and they enhance it, and it gets all pixely. That's a non-vector based image, right? So if you use like Paint or something like that, a lot of those programs they don't use vectors. Photoshop is a good example. Photoshop is not vectors.
Although it does have a vector.
It does have vector. Yeah, you can do vector stuff with it, but Illustrator would be your go-to. That's why you use Illustrator if you can use Illustrator as one of I've listed it here as a popular package you could use.
What form does it take usually? Is it SVG or what?
out of this, what I'm creating out of this is it's a shopbot part file, is the final thing. Vectrix has their own file name, but you can save it as OBJ. Depending on what software you have, you may be able to handle different things. So if you Google like free clip art or free 3D images, you're going to get all kinds of different things. OBJs, there's like a dot 3D something. There's like a dot, there's so many different ones.
Now, just to clarify, because I'm sure there's a lot of people who still don't get the vector business, just for ease of understanding, vector is like solid line and non-vector is pixels, broken up. I mean, just for a basic idea.
Essentially, yes.
Yeah, just an essential basic
Yep.
idea, because it's not an easy thing to understand.
No.
You're using these programs.
That is absolutely true. And in fact, one of the difficulties I had when I really started using vectors is I was used to more engineering type software where you would say like, my line must be this long. Like I can make a line in CAD, let's say, and you type it in and it's this long and that's it. Vectors aren't like that. Yes, you can make them individual lengths. Yes, you can measure them, but they're meant to be moved around and squished and expanded.
Yeah, so if somebody takes a screenshot of something and they enlarge it and it gets all pixelated, that's not a vector. But if they take a screenshot and enlarge it and it stays pretty much the continuity, then that's a vector.
Correct.
No, it's,
Well,
well, not if you take a screenshot.
not if you take a screenshot, but
All right.
if,
But essentially, enlarging, it goes down.
vaguely, yes. Here's a vector right now. I just drew this little circle up here. You can see clearly the nodes that I'm talking about. This is just something you have to get used to if you're going to do this sort of thing. There's a green box up there at the top. That green box is the beginning. So this is a circle, not supposed to have a beginning and an end. Well, in vectors it does. Okay? You've got various nodes as you go around, which in a vector you can individually push and pull to distort and do different things. It's kind of the beauty of vectors once you get into them. You can make this circle as big as you want it, and it will always be exactly the same circle. Okay? There's also another benefit of using a program that's native to doing drawing for CNC is that they tend to create cleaner vectors. This is a problem that I often find with Illustrator. Illustrator is a program that at the end of the day is meant to illustrate a thing. They don't particularly care about cleanliness. Once you flatten it, whatever it looks like is what it looks like. If you go to machine that, and you've got a little thing like that somewhere, it's going to machine the little thing like that. So using software that's really meant for this kind of thing is probably a good idea. Not forcing you to do it, but it's probably a good idea. Pre-made 3D clip art, again, it is not the enemy. There's so many sources from it. If at this junction I could recommend the lovely Dover Pictora books, I've got about 20 of these.
I love Dover.
Well, the Pictora version, you got to get the vector version of Dover books, not the other ones. You got to get, these are the vector ones. These have, what do these have? These have everything. These have EPSs, SVGs, and JPEGs.
But they're basically on a CD.
Yes, they are on a CD.
Yeah, okay.
And then I download that and upload it to Dropbox, and then I can get them from everywhere. They're also right free. So you can use them for your work that you might sell at, somewhere. Like Showcase. That's what I was thinking. And you won't get in trouble because you can do it.
Of course, there's no Beatles things in there either.
Yeah, well, but they're a great source. This one right here is out of this, Celtic book. And you can take something from there, pop it in your software, and 15 minutes later you've got something like this, which is really cool to have something to be able to show that quickly. I was thinking earlier This may be the first thing that I made on my CNC. I'm thinking it was either this or maybe one of these two little guys down here. Totally just clip art, unmodified.
Now, I have a question.
Yep.
Okay, so that's your first one,
I think so.
and I think that's great.
I think so.
Now, if you were to make it again,
Yes.
would you have make it deeper things for the underneath?
Well, I wouldn't have made it out of MDF. That's the first thing I wouldn't have done.
But I mean, the over and under, you would be able to do that now.
Now I would be able to do a lot of different things on that. When I first started, I had the ShopBot version of VCarve Pro, which has limited capability to modify that sort of thing.
Okay,
Now that I have Aspire, I can do whatever I want.
okay.
Now, there's nothing special about this. This is actually a flat file that I ran an automated VCarve toolpath over. So it's a special toolpath that just figures out how to do VCarving. This happens to be a piece that takes to VCarving really well because it's got a lot of points in it. So you get a lot of that up sort of action. There's some images like this is also V-carved, but it doesn't look like anything because it's all kind of really small and tight. You learn to kind of deal with that. But you can make stuff pretty quickly. Be creative. Have fun. Save your file. Try a new thing. You can always go back. That's the beauty of it, you know? Make 5 different files and try it 5 different ways. You can always settle on one thing at the end before you machine. Not a big deal. Dave, you use Rhino?
I do.
You use Rhino. I use Vectrix Aspire. You've also got, you could make objects out of something, if you've got the money for it. You can make something, you could use SolidWorks. You could use Fusion 360 is a really popular one. There's so many different ones out there that you can use for this portion. Again, I would recommend if you're just getting started to use something that does both your CAD and your CAM just to make it a streamlined process. The basic version of this software I think is either free with your machine or a few $100s, something like that. It might be even cheaper than that now. Yeah, well, okay, so here's the thing with them. Vectrix, I'm gonna give my plug. According to the president of Vectrix, who I met a couple years ago, they are committed to the buy it and own it model of software. Take that for what it's worth. Yep.
So a lot of the software companies will give a hobbyist or someone under a certain threshold financially a free license to use.
Yep.
Something like Fusion 360, that was one of them. I think there's several others that do that.
Yeah. It's one of the reasons that if you look at what various schools use, they almost always are using one of, you know, a set of packages, because a lot of these companies are really good about getting you to want to learn their thing before, you know, it's like why I went to RPI. RPI uses well, they did when I was there. They use SolidWorks. Now I'm like desperate to get another copy of SolidWorks, you know what I mean? But I can't afford it. It's just like the sooner they ingrain it in you when you're a student, the better, and then they get their hooks into you, and then that's what you want to use.
It's like the pinnacle. It's like this is the best.
Yeah, exactly.
They bring
And you
what
become
you-
proficient in it, right?
Yeah.
And your fingers just do the thing that your brain says after a while, and then when you switch packages, it's not that way anymore.
You also want to say that if you know a teacher or you have a student, they also have academic licenses for those too that are very reasonable if you can find
Yeah.
somebody.
And my second plug for Vectrix is they are lovely people. And they have so many videos and like skill builder projects,
Would you like
free
to write
files.
their name on the board?
I have it here somewhere, but yeah, I mean, if everybody's okay with that. As I said, they are out of the UK. They do a user group meeting in the US once a year. Next year it's going to be in San Diego. If anybody wants to think about going, I will be there. I went to their UK one, I think in 18, and had a great time. They get also, for the US one, they get all sorts of people to go. They get companies to go and show off their latest and greatest. I won a raffle to go down to ShopBot for a training session. I mean, you get all sorts of fun stuff at these things. Free, you know, there's always free swag. They get people who are doing crazy projects to come and give talks. It's fantastic. I would highly recommend it. Hopefully we can all travel, you know, reliably in the near future. It's fairly inexpensive to attend. And I've always gotten a lot out of it, just to meet other people. It's like this sort of a thing, right? You're in a room with all these people and everybody knows something different. You know, you've got like retired guys doing a thing here, teachers here, the president of whatever company is here showing you what they're into. It's really cool. Okay, so let me just jump back over here real quick. We've already actually covered a little bit more of this than I was. How am I doing on time? Yeah, I'm being a little loquacious. We'll have to. In this software, as I said, a lot of this stuff, you can just look at it and know what it does, right? I mean, you've got a line, you've got a circle, you've got a square. You draw stuff out. You know, you make circles in circles. You just play with it until you find what you need. What did I find over here? I have now Aspire comes with a significant amount of clip art.
What version are you running?
I'm running 10.5 point whatever. I've not upgraded to 11 yet, although I'm sorely tempted for sheets because I use sheets a lot. There was a pretty big upgrade from the previous couple of versions, especially if you're in if you like rotary tooling. Not in 11, but into the 10 and 10.5, I think, had a lot of different stuff.
What would you say the learning curve is with Vectrix compared to other softwares? Is it comparable or?
Whoops, I can't do that.
Just a reminder that people on the streaming can't hear the question. So you might
Oh, okay.
very
Cool. So the question was the learning curve of this software versus other softwares. I don't have enough experience with other software and teaching other software necessarily to answer that in a definitive way. I will say, given the level of support that they provide, it's probably pretty good for Vectrix. I think going into something like Rhino, you use Rhino for your stuff. I don't find Rhino to be easy for me to use.
It's a pretty steep learning curve.
It is a very steep learning curve. When my wife looks at the Vectrix software, she just shakes her head. It's so simple for her because she's really deep into Illustrator. So she looks at this and it's like, well, yeah, you can do that. Like everybody can do that. You know, it's that kind of a mindset. So the answer, I guess, lies somewhere in the middle. It's going to depend on what you're used to. If you've never used vectors before, I think they make it really easy. I've never used Fusion 360. I can't answer that. I've used SketchUp. I've used significantly. I think they've gone a little bit, since Google bought them, they've gotten a little weird. I'm not crazy about it anymore. Solidworks, I know. I'm desperate to get Solidworks again, but honestly, I use this for like if I need to build a shed. I do everything, and even though I'm not going to make it on my CNC, obviously, I do all my drawings on this because I can do all my measurement and everything really easily on this. So I think it's pretty good. I've heard good things from educators certainly about it. But then again, they're already invested in it, so it's hard to say. It'd be what I would recommend.
You need to have a separate computer dedicated to your CAD and CAM operation.
So I use one.
Can you repeat the question?
Oh, I'm sorry, I've already forgotten. Do you need separate computers? are you basically asking, do you need one for doing all the design and another one in your shop? Or can you run the machine and do the design on the same computer? That's what I do. So what I do is I have a desk in a clean area. It's next to my laser because that has to stay clean. I do all my design on, this is actually a new laptop, my other laptop. I do all my design. If you have software that can do all the simulations like this does, you get a really good idea before you enter your shop what's going to happen, which is really nice because you can kind of plan for your hold down. You can do a lot of different things. Then I just lift this up and I take it over there. I hook it in. It's mine is USB, so you do have to be connected to it.
USB to the router then, the machine?
Yes. Yep. It's direct connection. Mine is direct connection. And I have a little desk and I plop the laptop down right there. And then we go from there. We do all of our setup.
It's directly from your computer and not from the cloud.
Correct. Correct. Vectrix they have an interesting setup. So as I said, they're dedicated to the you buy it, you own it, and you only pay for the difference in price to upgrade. Which I think is fair, personally. Because to me, I don't like that I had to buy a thing and then have to pay another thing to use, pay another fee to use the thing that I already bought. I can't get my head around that so much. Plus, then you're talking about a situation where you have to have strong Wi-Fi in your shop, and not everybody has that. That can be a problem. So, and what if you're on a plane or a train or something like that and that doesn't have Wi-Fi and you want to do some designing or something like that? Now you're beholden to having to have that to use your own software. I just don't buy it. Vectrix System, basically, when you set everything up, you link it once to their server, to your account. The two things link. It says, yep, you're good. Then you never have to do it again until you upgrade your software or buy something. Then you do it again. It links. Boop, you're good. Now, I have everything because I just uploaded this version of the software onto this computer. I could download all of that clip art onto this hard drive and it would live natively here. I have not done that yet. On my other one, that's what I did because I would never be without my clip art and all of my tools. So they let you do it, not a problem.
How big of a hard drive do you have?
1 terabyte solid state in this one. My last one had a 512, but it was spinning disk. And if you're going to be in a dusty wood shop, I would recommend not having a spinning disk hard drive. And use the best dust collection that money can buy. And get one of those little air cans, and just keep stuff as clean as you can possibly do it. And maybe consider not being stupid like me and cutting MDF. That's just the reality. Because it gets bad, and you know how these things nowadays suck in air. It's all heat. Oh no. Once we have everything drawn, how we like it, we'll jump over to the cam portion. This is really what's going to be the bridge between what you've drawn and the hardware that's going to make it. It's going to create tool paths, which are going to set up a machine code, or usually it's some version of G code. There's a couple of weird little other ones. I think even ShopBots is slightly not totally G code, but I might be wrong on that now. They have like a weird little thing. This is where you're going to do stuff like set your feeds and speeds. You're going to select what tools you're going to use. You're going to add in things like leads and tabbing. So if you don't want to just stick the bit right down in and kind of, spin it around, you can kind of do nice little lead ins, make things nice and smooth. You can set all that kind of stuff up. You're also going to need to make sure that your CAM package has a post processor for the tool that you have. Okay? If Your tool isn't going to be able to read every single file type that the software package can output. So once you set it, it's one of those things you sort of set it and forget it. But you need to make sure that that is something that you have. If you have a tool changer, you need to make sure that the software that you're using can use a tool changer. When you get started, you're probably not going to have one, but they're mighty nice, but they're also mighty expensive. Talk about those in a little bit. Popular packages, again, VCarve, Fusion 360 has their own Mastercam. There's a bunch of like, you know, industrial ones. What's the one I'm thinking of? There's a whole bunch of different ones, you know, just for plasma or just for machine operation in industrial environments. That's really overkill for this sort of thing. Jump back over here real quick. In this software, that's everything on the right side of this screen. So we've got a bunch of different choices over here that we can use, and they're pretty, this again, I think this is where they keep it sort of simple. They keep your number of different choices down to like big idea choices. So, profiling. You got a circle, you want to follow the profile of the circle. Pretty simple. Pocketing. You've got a flat surface, and then you want to make, now obviously this one isn't pocketed, this is, you know, but you want to just route out this area in here and make like kind of a dish sort of a thing. Pocketing. Drilling is exactly what it sounds like. You make a bunch of drill holes. Very helpful in solid surface manufacturing, where you might be doing things like hinge, you know, the little insets for hinges and stuff like that. You just go along and pop them all in there. This is a new feature, thread milling. Yes, you can do wooden threads natively in the software. Yeah, that's fun. That's a newer feature in this. We've got some engraving things, inlays. It can figure out how to do, it lets you set your own clearances for inlays, so it will create both the pocket and the inlay and figure out how to do those two together. There's one back there? Okay, yeah, cool. I haven't tried it with how that's designed, but yeah, I've seen lots of examples. It works really well once you figure out with your materials how you're going to do it. You need a little playing around with it, but it works great. V-carving, like this guy over here. Photo V-carve is a special thing in this. You can actually make things out of wood that look like a picture. Is there a lithophane? Yeah, lithophaning, which is super cool. Essentially machining back and then adding a texture to the top. You shine a light through the bottom, it'll show you an image. Very cool. Great use for scrap corian that you have laying around. Fluting. You can make it do all your fluting for you. Texturing. I've got some examples of texturing in some of my pictures later on. If you have something that you want to make look like fish scales or old wood, something like that, you can program the software to do all sorts of crazy random texturing. Prism carving. I do not have an example of prism carving, but it's exactly what it sounds like. It's essentially the reverse of V carving. So it cuts away everything, and then your letters would stand up in a prism. This software also has support for moldings, chamfering, and then we've got roughing and 3D finishing tool paths. So if I were going to actually do this, this is the apple again. If I were to do this in real life, I would use a roughing tool path first with a big old bit. Maybe not this big, but you know, something like this, to hog away all the material that we don't want and leave a fairly thin skin above the actual image. Then I would come in with something like this tapered ball nose, and I would use just the tip, and I would go back and forth and take off that last bit of skin and reveal the actual image underneath. You save a lot of time and very expensive, tiny, tiny tools doing that. Well, this is a good time to talk about my mistake bit. I made it with this bit about 6 inches before it broke the first time I used it. I think this is a $50 mistake. And this one's quite small. When you start looking at this guy, yay, 70, 80. Solid carbide. Some of these onsrudes are up there. Personally, I like the Amana spectra-coated tools. Personally, that's what I like. I like their nomenclature and their naming convention. I like their containers. I like their coating.
Where are they made?
These ones are a mix, I believe. This one is made in the USA. This one is made in, actually, they're all might be made in the USA for their bits. I'm not sure if their saw blades are made in the USA, but I think all their bits are. The onsrudes are, they're not Norway, they're over there. They are extremely high quality. I'm not a huge fan of them. That is what ShopBot will try to sell you. Mainly because they're a little bit harder to get replacements for. So when I spec out a job, I spec it with a new bit to run the job. I buy the bit and I don't start until I have the replacement one that I'm going to use in my hand ready to go. Because if you get into this and you break this mid-run, it's very easy to go to that line of code or the one right before it, put your new bit in, and start again. You don't have to start from the beginning, but you got to have this there to do it.
What causes the bits to break?
Heat and too much pressure. That's heat and too much pressure and stupidity on operator error. Dropping them on a concrete floor, kiss them goodbye. If you've decided that you like sheetrock screws for your hold down method, or you like Bessie C-clamps for your hold down method, ductile iron and carbide are not compatible, so don't do it. This one was just heat and operator error, honestly. You need to figure out, I have a little formula on here I can show you, but doing a chip load calculation is going to be what you need to do. Sometimes the manufacturers, Amana's got a whole sheet you can look at that'll kind of give you some guidance on these things. But when you talk about doing 5-6 hours of machining without stopping, you got to have your heat right. You got to balance heat, how much heat is coming out in the chip, to how much time you want to sit there and watch the thing go back and forth. And that's always the balance that you have to do. Yep.
Are you blowing like cooling air on the bit as well as evacuating the chips at the same time?
So the question there is, are you basically providing active cooling, essentially, right? A lot of that you're going to get out of the dust collection. If you have a high CFM dust collection, I run a Jet DC 1100B with the big canister. If you stick your hand under there, not when it's running, for God's sakes, you get a massive amount of air coming up through there. Mostly, though, the heat is coming off in the wood itself. Believe it or not, it is. Some of it's going up into the router. Some of it's coming out in the form of static electricity. Some of it's which we need to talk about because that's important. You've never encountered static electricity like a CNC can put off. But yeah, most of it comes out, heat. Heat is bad, very bad. Yep.
You're not using cooling air.
No, now if you're gonna set up your CNC to run aluminum, yeah, you need to start thinking about that a little bit more. But most of the time it's going to come from the air, because what you do is there's a big dust boot that sits down over the top of the bit while it's working. You want to create the best seal that you can, so you're getting all that air getting sucked right up in there, out into your dust collector. So you are getting a lot of heat that's coming with it. But the main thing is going to be dealing with what you've got actually in the hole, so to speak, as you're machining. Because no matter if you get a bunch of chips jammed up in whatever you're hogging away, no amount of air is going to help you in that situation, because all that heat is down in that hole. So you need to get those chips out of there. There was a question in the back. Yeah. I don't know of one. The question was, is there anything that you can use? I will get there eventually. Is there anything you can use to monitor the temperature? Your ear? No, but I haven't seen one, but you might be onto something there. If you could have it exposed, you could point an IR thermometer at it. A lot of what you're going to get, though, is experience with listening to the tool as it goes and knowing when you're in the sweet spot. You know, does it sound right? Does it smell right? Because when it starts burning, you're going to smell it a lot. And then you just stop, you know. But I don't know of a system that does that, which I'll make a note of and hereby patent. Okay. Yep. Time check. Do we want to keep the questions down and just get through this a little quicker? Let's do that. Okay. Then we're going to do our machining. Everybody knows what the machining looks like, right? Goes back and forth, makes a lot of noise, dust comes everywhere. Your choices in this are going to vary. There's so many variables. Price, space, power availability. Remember, if you don't have three-phase power, don't spend the money on a machine that has a three-phase spindle. Just don't do it. You know, if you're in an apartment and they have a guy next door who can't stand the noise, CNC might not be for you. So you need to think about those sorts of things. Reliability and expandability kind of speaks for itself. I personally would not purchase a machine sort of sight unseen off of eBay that comes in a kit and whatever unless you're really into tinkering. I would buy it from a name brand manufacturer, hopefully with a warranty, and good customer support. Hopefully US-based customer support, like ShopBot. Choose robust tooling. Solid carbide is probably going to be your best bet unless you're into a lot of foams and you want to use like a titanium nitride coating. Sometimes you can get away with that. Don't go to Home Depot and buy carbide tipped high-speed steel. You'll get part of the project done and then probably not much more, or you'll just break it. Keep safety in mind. Hearing protection, eye protection. You do it when you're in the shop, hopefully. Yes, everybody does it all the time. Really do it, because when this thing breaks, that bit, your eye, they're right there, I'm just saying. And employ reliable dust collection. Now, there should not be noise, but we'll see what happens. Now, I tend to run my feeds and speeds fairly conservative, because I don't really care about production times all that much. This is just a quick video of my specific tool running a job in acrylic, I think it is. I believe with this Onsrud Super O flute bit. Not an off-the-shelf type of thing that you're going to get at Home Depot or Lowe's. You would order this. This is especially for plastics and hard-to-machine, highly figured things. Really good bit to have. I would suggest getting one right away. There was sound, which will demonstrate, if it were on, exactly how loud this sort of thing can be. Luckily, we don't have the sound turned on. Oops. No. And that's what it looks like when it's done. This happens to be a mold that I made for Russian Easter. You put cheesecloth in it, and then you pour, I don't know, this battery sort of stuff in there, and you end up with delicious dessert. So, you know, I don't know about that part of the process. I can only speak towards this part of the process. But you can do some cool stuff. I used to process a lot of plastics before I got a laser. It's really cool. It's a great tool for this sort of thing. Quickly, just go through some of the possibilities. Woods, plastics, non-ferrous metals, foams, signage. You're going to be using maybe high-density foam type product. CNC is how you're going to get it done. Great for that sort of stuff. We got an example back there of the wolf head, yeah? Good stuff. Yeah, they have a copy of that hanging in their offices. I was wondering, once I heard wolf head, I thought there's only one that it can possibly be. I was going to say, it's like I know, as soon as you said it was that, I knew which one it was. Highly expandable. These days, there's so much that you can do. You can get add-on modules for scanning objects. You get a little touch point, and it goes through, and it ding, 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 ding. Next thing you know, you have a object that you can use. Pretty cool. You can add on lasers, which I'm a little of. I'm not a huge fan. Plotter pens, if you're going to be doing, I don't know why, but basically you can get a Sharpie, and you can stick the Sharpie in the thing, and it'll plot stuff out. Maybe useful. Drag knives, if you're going to be doing vinyl. There's a special tool path for drag knives in this, where you can actually do the little loops at the end, much like you would do in a plasma setup. Ernie converted one to plasma. Great use if you've got a, maybe you're upgrading to a bigger machine. That's kind of what I'm planning to do with my current one. Turn it into a plasma cutter when I'm done with it. I would not recommend trying to run metals and woods necessarily on the same machine. There's so much cross-contamination. It's just, maybe just don't do it. If you're into slabs, get a big old slab, put it on there. Basically, you'll run a flattening routine. Nothing flattens a slab like a CNC tool. It is like the definition of what CNC tools are kind of for, is just going back and forth in a flat plane. Great for flattening slabs. If you get a small system, maybe travel with it. Take it to a craft fair, something like that. Set it up right there and use it. If you're outdoors, you maybe get away without the dust collection. Hard to say. I'm not advocating one way or another. And I think importantly, may provide opportunities for folks that maybe can't get into the shop and use some of these other tools that we see out here around us, right? This is definitely a technology that opens things up to people who maybe aren't mobile, or maybe can't, do sawing or something like that. This is a really cool thing, and lots of stuff you can do. I'm going to bring up dust again. Dust and grounding. Deal with grounding. If you touch a hose after you've been running a flattening routine for 15 minutes and you don't have the whole thing grounded, you're going to get an awesome shock through that hose. It's going to be amazing. Trust me. You don't want to start fires. You got the thing set up in your wood shop. Maybe you got some vapors from your finishing something over here or something like that. Not a good thing to risk. Hold down. We didn't really talk about hold down, but a lot of choices. Screws. I am a huge fan of this double-sided made in the USA turning tape. I love this stuff above all other hold down options. I love it. Adds a little bit of cost to each project because you have to replace it each time you put something down. But I think it's great. You can use it for a lot of different things. You saw right through it with your bit and it doesn't matter. If you're doing something like vacuum, as soon as you cut a hole through, you've obviously lost that little bit of your vacuum. So it's going to get less and less awesome as you go along unless you have some sort of a zoned system. Tooling can get expensive, can definitely be noisy, and again, power availability. Just check what you've got. You don't want to have to hire an electrician to like fix the purchase that you just made, you know, to install 220 if you didn't already have it, and now all of a sudden you've got 30K invested and you need it. That's not a great place to be in. Spend some money now. I pulled some prices the other night on various levels of systems. Everybody leans, I saw a bunch of people lean forward a little bit. This is the part. Now, this is just for the machine, not the laptop or the dust collector or any of that other stuff. You want to buy a kit, you could, if you're really handy, you could 3D print your own. I've seen people do that. I'm not saying that's a great idea. Hobby machines, you're looking at anywhere from $100 up to $1,000, depending on what you've got. A lot of that's going to be the router or the spindle. If you're running off of like one of those little Bosch Colts, which a lot of the small ones do, pretty cheap. Not made for the demands of, you're asking those bearings to do an awful lot. Just going to say, going to get loose real quick. Desktop machines, I didn't see what we have in the back there. Assuming you don't build your own or get a kit, you're looking at anywhere from $1,000 to $9,000. ShopBot's current top of the line one, I think with automatic tool changer, is hovering right around $9,000. You'd be looking at somewhere in the 1.5 by, might be 2 by 4, it might be that big. Pretty good sized bed. Decent sized bed. You do a lot of stuff with a 2 by 4 bed. Full size machines, again, pick a number and double it. You can get a reasonable machine for somewhere just north of 10,000 for, you're getting into a full size type tool. That's probably not going to get you a 5 horsepower spindle and whatever laptop to run it, but you can get there. A lot of stuff on the used market, if you know what you're looking for. If they can demo it for you, for example, before you pick it up, go for the used market. If it's from a reputable company, they're going to have parts readily available. They're going to have support readily available. Not a bad choice. You're going to have to choose a traditional router or a spindle. The router is getting more and more difficult. I'm probably behind the times. I'm hearing now that Porter Cable will no longer be making routers. Is that correct? That's what I have read. I know. Everybody sat back up after that. On mine, I run a, what is it that I run on mine? It's like a 3.5 horse Porter Cable production router. That's what I run on mine. It's a monster. It is very loud. Yeah, 7518 is what I run. A lot of the other ones are going to be using, if you want to go router, you're going to go that Porter Cable 890 form factor, sort of that kind of size. You have so many choices in that size. That's actually a good choice.
So I'm confused.
Yep.
So you're saying a router in addition?
So the router is actually the motor that you're going to put the bits in and do the cutting. All the CNC tool does is move the chassis for the router back and forth and up and down and turn it on and off. Now, if you have a spindle, it can probably also do speed control and some other things.
Okay.
This is why I said you're probably going to have to consider these separate purchases because you've got decisions to make there. There's trade-offs for both.
I didn't understand that part was not part of the machine.
I mean, it is, but quick question.
How does speed play into the price of the CNC? So your lesser expensive ones are slower than your more expensive ones? I mean, I was never aware until recently how slow a CNC can be.
So the question was on the speed relative to price, basically,
Yes,
right?
that's what I'm asking.
So again, there's a balance here. If you have a 7 horse spindle, you're going to be able to physically push the bit into the material faster. Whether that's a good idea or not is a different question.
Yeah, with workforce or whatever. Okay.
The other thing you have to look at is whether or not if the machine skips a step, whether the type of motor that you have on board can realize that that's happened and correct for it. So there's going to be a major price difference between machines that can do that and can't do that. For anybody that's into computers and stuff, this would be like non-error correcting RAM and error correcting RAM. One can kind of do it, the other one can't, so you can miss steps. When you get super hot, you're busting through there, and all of a sudden it's like starts clicking and doing weird things.
I was comparing it myself, and like say with 3D printers, I can't stand watching the slowness. It just
Right.
drives me insane. And I thought CNCs were much quicker.
In 3D carving, they can be significantly quicker.
Okay.
In cutting,
Okay.
they're going to be fairly slow, depending on the material. Cutting 3/4 hardwood plywood, going to be slow.
See, when people think, I know a lot of people when they think of a CNC, they think of using it to cut multiples.
Yes.
So, I mean,
Yeah.
you know, some of the stuff you've shown us, I hadn't even thought of, you know, but
The one-off sort of a thing, yeah.
a lot of people think of them to cut multiples.
In the industrial environment, you're looking at solid cabinetry, solid surface cabinetry, that kind of thing. They're going to make 1,000 doors out of some kind of MDF. They're all going to get moved off to the paint shop and then coated. That's what they're going to spend their entire life doing.
Or like 500 gil.
I would suggest purchasing a machine where that is not the case, where you can adapt it to all sorts of different environments. You can fit it into the shop that you want. You try to get one of those big iron machines. I don't see how that's, unless there's a roll-up door here somewhere, I don't see how that's happening. But we could fit a shop bot, for example. I've seen them put into closets like this bathroom over here.
I've been in many.
I mean, I've seen them in some crazy closets, believe me. The noise and the dust must be unbelievable in a little space like that, but you can do it. You can fit it through the door, put it together, and in a day you're up and running.
So one of the big problems of like possibly, say, putting one in here in a corner or whatever, we would have to really consider the dust removal and the
Yes.
noise issue.
What I would suggest if you're going to put one in here is putting up these plex walls around it,
Right.
and then making sure that part of the training is that the dust collection gets turned on, and then calling it a day.
Yeah. Okay, thank you.
Or one of those those flexible like tent enclosure things with the clear plastic.
Right.
Those are great.
Yeah.
Something like that. Yeah, absolutely. The training is a whole different thing though. So, and then incorporating into the into the wood shop. Great way to add functionality, as I said. Creating templates for your own hand router work is amazing with this. Make a lot of cornhole boards or something like that. You don't necessarily have to put the surface onto the CNC to do it. You can just make a template and then move it and just and then move it and then or you want to make a hole on the wall here, smack it onto the wall, make your, whatever you want to do. Great for making templates. Adirondack chairs, making templates for those. Transferring those fancy paper templates from all the magazines into a format that you A, won't lose, and B, can make whenever you lose the first one that you made. You can always make another one. Custom jigs, custom tools. A lot of people make their own tools. Center finders, that kind of thing. Awesome for making your own tools to a high degree of accuracy. And embellishments to other things. I mentioned power, noise, all that. The good news is if you have a workshop like this, you probably already have power. You probably have a population used to using safety glasses and earmuffs. And you've got a population that knows about dust. So it's a great place to retrofit one into. If anybody has questions about going beyond the very basics, I would be happy to answer them. I mentioned adding in lasers, 3D scanning. I didn't mention rotary, but it's basically sticking a lathe on your CNC so you can do round parts. You replace one of your axes. Let's get into show and tell, because that's the fun part that everybody wanted to get to anyway. This is just some stuff that I've done. Walnut, I don't know, wall clock thing. Project that I downloaded. I think it was a free one from Vectrix. Now they didn't do it in Walnut, and I added some other embellishments, but pretty good little project. Get around Christmas time, you're thinking about what you're going to get people, spend some time in the shop with the CNC. Next thing you know, you got all of the stuff you need. 20-sided die. Love that one. I didn't show the bad side of it where I did a poor glue job. Dave, this is one of yours? Ernie's. Okay, well, I'm sorry. Ernie's one. And now is this, I was unclear, is this two-sided? Is this two-sided machining? Two-sided. This is a cool thing that a lot of the software can do. If you don't have a rotary to move things from side to side, you can program the software with two sides and then flip it halfway through the job. Good. So we'll check out those. One on the left is a hybrid job that I did. I set up there's a special little widget you can download to make tabbed boxes. So this is I actually flew with this box, which was exciting going through I had to design it so it'd go through the scanners because I didn't feel like opening it up. And then I made my own laser engraved barrel top that sit down in it. The lid comes off. Then I laser engraved all my logos and stuff down on top of it. Thing on the right is an electrical box cover, if you can believe that. So just a guy that I know at work has a camp. He's got a real electrical box. Don't worry, it's not like covering circuits. I've got some of these samples up here. The finished product was on the right. It's about 6 foot wide, hanging. It's supposed to go above a Viking bar. So you've got chalkboards the whole way around that are removable. The whole thing breaks down into a crate about as big as that TV stand for storage. Pretty cool little project. Got some fun stuff. The one on the right is not up anymore in Troy. I have all the parts to it now. The one on although if you do drive down through Troy, Market Block Books, in the front of they have a V-shaped building. There's 2 things that say books on either side. Those are me. The B is upside down. It's not my fault. They hung them that way. One on the right is a driveway marker from my mom's old house in New Jersey. She's really into hippos. Again, fun thing. You can just sort of do this sort of stuff. And we were going to have, at this point, a live demo, but that is not going to happen now. So I think whatever time we have left, we'll do show and tell of live stuff and questions.
Thank you, Kurt.
Yep.
And later, if you have other questions, Kurt can answer.
And if I don't have the answer, I will foist it off.
We're going to go back here to, if I can change it.
I should turn this off now, right?
This is 3 pieces. Yeah. Damage, and then a piece in the middle there. Is this on? Anybody hear me? I don't know if this is on. Nope. Says it's on. Oh well. This is a lithophane. You hold it up to the light, you can see a face in it. These were done hundreds of years ago. They used to engrave the bottoms of beer steins. They used to engrave naked ladies on them. The guys would guzzle down the beer, hold it up to the light, and then they would refill their steins.
Now we got not a naked Ray Gannon.
No, this is Ray Gannon. He used to be a member of the club here for a long, long time. These were actually 3 pieces that we did on our router. He did a left side and a right side, and then a piece in the middle, and glued it together. This is 2-sided. These are some Corbels. These are made out of Jatoba. Several years ago at Showcase, they had a challenge. Curtis gave us a bunch of Jatoba. So Ernie made the horse, and he made the Corbels, or bookshelf. It's got seahorses on them. These are heavy. And then we're in the carving group, so we were always getting teased about cheating. Make it look like chip carving, but using the CNC. Didn't get any miscuts on this. Now this sign here is Vectrix. My husband and I were the first people in the country to have the Vectrix software. They gave us the software. We made the 4 signs, plus we were able to get about 6 of their plans that they purchased. So we made 2 of them, and the one is in England in their offices. But they use this in their literature, their sales software. So we presented this at ShopBot. They had a 3-day jamboree type thing. But it wasn't done on a ShopBot. It was a homemade router that we had. This is made out of high density urethane, and that's real gold leaf. So we had to make some chickens for a sign. I have a sign business. So somebody wanted some chickens on their sign, so we carved some out. And then Ernie did these birds. This is my favorite. It's a ulu bowl made out of, for cutting, made out of firewood. So Ernie managed to come up with the design so that the curvature fits the curve of the blade. These get used every day. These are parts. There's a kayak company called Wavewalk, and we manufacture parts for them. These are a support bracket, and this is a motor mount for the kayak. And this is an inlay. He was talking about doing the inlay. This is an inlay we did using the Vectrix software. So we didn't have to do any sanding. The way it came out, we were just able to plop them down in there.
No sanding?
Mm-mm. Nope. Nope.
But the CNC, it will finish to like a 400?
We sanded it down first, the top.
Okay.
But as far as all the pieces and in the holes, no sanding.
Oh, okay. But okay, so, all right.
And then we applied the finish on the top. So. And the fish bookends that they had, he actually did, it was 2 pieces, a left and a right, glued together. And then he mounted them on the wood part. That was something something we bought from Vectrix, the plans, the files for it. So. Any questions?
What does it say? I can't see it from the
Howling Wolf Inn. It's not a real place, but Vectrix gave us 4 files, and we made the signs for them and painted them and presented it at ShopBot. We didn't own the ShopBot. Ernie had made 3 CNC routers himself from scratch. But they had a 3-day thing down in Raleigh, North Carolina area, and my grandson was two months old, so living near there, so we went down and we presented this. We had to give a talk on it. So now we have a shop bot. We've had it. We did this about 15 years ago, and we've owned a shop bot for 13 years now. We got a 5x8 shop bot, which back then cost us $16,000 plus. Anything else?
If you transfer the mic to me, I'll say
It's not working. I don't think it's working.
It is. I'm going to get the mic.
It was working. I didn't.
I'm going to go
I
around.
just want to kind of see.
So I also brought a few examples of things that I've made over time. This one was a logo for a timber frame company. On the braces they would put their logo on one of the braces of the timber frame. I made this before I got a laser engraver. These days I would use a laser engraver to do this because it would be easier than a CNC. This was a project where they wanted a design on a bunch of door panels, interior door panels, and they wanted it intentionally choppy look to kind of simulate maybe a roughly hand carved kind of look. This and this one are a couple of small jewel or accessory boxes that were made on the CNC. The body is hollowed out on the CNC. This is butternut, and then the lid is made in 3 parts. Except for the inlay, that is, the maple part is made as one piece, and then the outer rim is made in 2 pieces, and then captures the rest of the lid inside. This is kind of an unusual one.
Okay, can I ask, how long did it take to hollow out that oval box? So
I can't remember offhand. It's been quite a while, but maybe 10 minutes.
to hollow out the inside of that?
Yeah, maybe less than 10 minutes, maybe more like 5 minutes. This is kind of an unusual one. A violin maker invented a particular shape of tailpiece and patented it. And this is for viola, and this is for violin. This kind of shows example of how it comes off of the CNC, and then what you have to do to get from the CNC to a finished product. In other words, what you get off the CNC is not necessarily the finished product in something like this. By contrast, this is a puzzle chair, where it's a puzzle because you can take everything apart and it lays flat. And this is an example where what you get off the CNC is the final product. It's just cutting out all of the edges there. this somewhat unusual project. I was making wooden swords. They're called bokken for martial arts practice. I'm currently redesigning this to make it a different, more oval kind of profile on the handle for them.
I was just thinking it was just a high leg, and I'm thinking, oh, I like the curve on the leg.
Could you hand me that trivet right there? And this is a trivet. So it's routed the same. It's one piece of wood routed the same from both sides to give that sort of interlacing pattern. Yeah.
Do one side and then turn it and rotate it and do the other side?
I do one side and flip it over and do the other side.
Is
So tell us about the dress.
is alignment an issue when you go to flip it like that to get it lined up just the way you want it?
Yes, it is. So I have I usually make, well, for something like this, and this is a production thing, you know, I make them by the dozens. I have a special vacuum jig that will hold it in a particular location, and then pins that will locate it in the correct position for the other side.
Dave, that's pretty long, that stick.
Yep.
How big is your machine?
Mine's a 48 by 48 inch.
I assume that's less than 48 inches.
It is,
Okay.
yes. It's close, but and finally, you were asking about this, and this, it's the body is cherry, the dress is basswood. And again, there's a lot of work after the CNC cuts it out. One of the features here is that it's carved quite thin, so it's less than 1/10 of an inch thick.
So it's very fragile.
So it's very light. It's somewhat fragile. You can take the dress off. I'm not going to take it off here, but.
Does she or doesn't she?
And so I started with blocks of cherry and basswood, and something like 99% of the original weight when you get here is gone, because this weighs about 2 ounces total.
So you had to carve it from both sides?
Yes.
How long did that project take?
How long?
Quite a while. You don't count the time on a project like that.
Just making the file.
Yeah.
Now, one thing he talked about using clip art. I tend not to use clip art. I tend to make my own designs. This was a case where I sculpted the figure in clay, and then used an optical scanner to create the shape, the digital file, and then I was able to use that and modify it to do it. So in my mind, that's a little bit like a sculptor who might sculpt in clay and then transfer to bronze or something like that. So
How hard was it to scan the 3D?
that part's the easy part. If you have the tools. So anyway, that's some examples of some different things you can do, and thank everyone for coming out tonight. Hope you learned something from the session.
Amazing.